All right, well, welcome to Cycle 5. This is Cycle 5's notes on solving equations when you have variables on both sides of the equation. Now, there's a little flow chart here. You can go through it. It's more like a checklist and see, if you've done everything, but I don't really pay too much attention to this flow chart here. So we're going to scroll down. And problems 1 and problems 2 will probably look a little bit different if you're using Notability. If you're using Notability, the problems got all messed up because I used a Word document instead of a PDF. So I apologize, but they are the same problems. If you're using Notability, just make sure and check that the operations or the signs in here, like the plus and the minus and the equal signs, because those got cut out of the Notability. So here we go. We're going to actually skip this side. We're actually going to go right to the back side because these equations are equations we've already done before. There are not equations on both sides. So as we go over here and look at our first couple problems, you'll see a really good difference right here with the x's on the left-hand side and x's on the right-hand side. I'm going to divide it by equal sign because that seems to help. Now, one of the things that I noticed as I was going through these notes with you guys in class was that you were mixing up when to do the opposite, when to subtract or add. So I'm going to go through here and explain it, and hopefully it goes a little bit better this time. First things first, always, if you can distribute, you need to distribute. So looks like here I need to distribute this -2. Okay, so then the 3x, nothing's going to happen to it quite yet. So it's just going to come down. But I have -2 times x, which is -2x. -2 times 3 is -6. And on the right hand side, nothing changes as well. -2x. Okay. Another thing that you need to do, you combine you distribute and then you combine like terms. So always distribute first, then combine like terms second. So on the left here, it looks like I can combine like terms. 3x minus 2x is going to be 1x. So now I have 1x minus 6 equals 5 minus 2x. And so now here we've simplified everything now, and now the goal needs to be, okay, I need to get my x's on both sides. Okay. Now, what I was telling you before, put a line through the equal sign. If your number that you need to bring across the equal sign, if you need to bring a number across the equal sign, you need to do the opposite. Okay? So for example, this -2x, if I need to move it over here to this 1x, I need to do the opposite, which is add, which is different. And some people are having some confusion, like with up here, if I look up here, 3x minus 2x, how come I don't add 2x? Well, the answer is because it did not cross the equal sign. Okay, here's the equal sign right here. If it's on the same side, like these ones are, then just combine them like you normally would. 3 and -2, that's 1. Okay? It's only when it needs to cross the equal sign that you need to do the opposite. Okay? So now back to here. We have x's on both sides. You can move this x over here. You can move this x over here. It doesn't matter. It doesn't matter what side you want to move your x's on. They just need to be on the same side. Okay? Now a little bit of advice to make your life a little easier. You want to try to move the x's to the side that has the larger number. So if we look at our two x's, I have 1x and -2x. Which one's larger? Well, if you said 1, that is correct, because 1 is more than -2. Okay, it is a larger number. This one is negative, so this one's larger. So I'm actually going to move this one right here over here. Since it's going to cross the equal sign, I know I need to do the opposite, which is add 2x. And then I'm going to do it over here too. Okay? On the right-hand side, it cancels. On the left-hand side, 1x and 2x make, and I'm going to bring this up here, 3x. So I have 3x, and I put an equal sign. I apologize. It's supposed to be minus 6 equals 5. Okay? Now, it's a simple two-step equation. We got our x's on one side. Now we can solve it the way we want. Add 6. Why do I add 6? And then finally divide both sides by 3. X equals 11 over 3. Please do not change that. Please do not change that to a decimal. Leave it as a fraction. 5 is very similar. 5, again, you're going to distribute, okay, and solve just the same way you did over here. So if you need help with 5 and want to do 5, watch this part here on number 4. It's very similar. Number 6, we talked about number 6 in our warm-up today. What to do when you have multiple fractions like this. There are many ways to do this problem, and some of you have learned those ways. And if you're more comfortable doing it that way, then by all means, whatever works for you, go ahead and do. What I'm going to do is something that to me seems easier because I don't like fractions. So when I look at fractions, the first thing I want to do is get rid of them. So if you're like me and you don't like fractions either, I'm going to show you a way to get rid of all fractions in one step. Okay, here we go. When you look at this problem, you'll see you have multiple fractions that you want to get rid of. How do you get rid of all of them at the same time? Find the fraction that has the largest denominator. We look at here and here. The largest denominator is the 6. So I'm going to multiply everything by 6. Everything. Everything in my problem is going to get multiplied by 6. So here you're going to see what happens. 6 times 3, well, that's 18. Here, when you're multiplying by a fraction here, remember that there is a 1. There's a 1 next to this g. So it's technically 6 times 1. Remember when you're multiplying, you multiply times the top and divide by the bottom. So 6 times 1 is 6. Divided by 3 is 2. So minus 2, and then there's a g there. Equals. On the right-hand side, notice that these 6's are the same. So those 6's are actually going to just cancel out. You're left with just a g. And then over here, 6 times negative 8 is negative 48. Okay. And now it turns into a problem just like you had above. Move the g's to the side that has the biggest number. Well, this is a 1 right here. So 1 is bigger than negative 2. So this negative 2, negative 2g, needs to come over here. Since it's crossing the equal sign, I'm going to change it to a positive. Okay. They'll cancel. So I have 18 equals 1g and 2g, make 3g, and then minus 48. Then you're going to add 48. Add 48. These cancel. On the left side, 18 plus 48 is 66 equals, and on the right side is 3g. Divide both sides by 3. 66 divided by 3 is 22 equals G. You may have solved it a different way and got the same answer. That's perfectly fine. As long as you get the same answer, it doesn't matter how you do it. Okay. For number 7 and 8, I'm not going to do the entire problem. I'm going to abbreviate it. And I'm going to do some of the work here, and I'm just going to show you what you're going to get. Number 7 and number 8 are special cases, which means that your answer is going to be a special answer. And you'll see what I mean. When I do this problem here, I get 4m minus 1 equals 4m and then minus 1. So after I distribute, I get this. Now here's the problem, because I told you move your m's to the side that has the bigger m. But when you look at them, wait a minute, they're the same. 4m and 4m are the same. Now, if you didn't know any better, you would go, okay, well, I'm going to just try to move the 4m to the other side. So since it's positive, I'm going to subtract 4m. And you go like this, and you're like, okay, this cancels. Well, wait a minute. This cancels too. What the heck? You know, and so the minus 1 comes down, and the minus 1 comes down, and now you're left with negative 1 equals negative 1. I no longer have any more variables. So this is why it's considered a special case, because your variables both canceled out, and you're left with negative 1 equals negative 1. Well, there's two possibilities here. Either this is true or it's not true. In this case, it's true. This is actually true. Negative 1 equals negative 1. So your answer is going to be all real solutions. Let me move that over so you can see that. All real solutions. What that means is no matter what value you put in for m, no matter what value, whether it's 1 billion or negative 10 million or 73 or 2, no matter what value you put in for m, you will always get an answer that works. Okay, so that is that special case. True means all real solutions. When we look at this one, what you're going to get on this one is 6x plus 12 equals 6x plus 7. So after I distribute and after I combine like terms here, this is what I get. 6x plus 12 equals 6x plus 7. Now here, by now, you should look at this and go, wait a minute, they're both the same. They're both the same, and you can probably already just go, okay, they're going to cancel. They're the same. Just make sure that when you say they're the same, they are the same. They're exactly the same. One's not negative. Okay, they're both the same. They're both positive, exactly the same. They both cancel, and so what you get is 12 equals 7. Now here's the other case where 12 does not equal 7. You get an answer that is not true. In this case, it means there is no solutions. Okay, no solutions, which means no matter what value you put in for x, whether it's 10 billion, 25 million, negative 70,000, doesn't matter what you put in for x, you are never going to get an answer that works. Okay, so these are your special cases. True is all real solutions. Not true, no solutions. Okay. So after that, we took a break and you guys worked on some of your homework. And then we came back to what are called literal equations. Literal equations are probably some of the most confusing math that we do in this class, just because of the fact that now we've completely gotten rid of numbers. and all there are a bunch of letters. And for some reason, this freaks students out, and people think that now it's impossible to do. They don't know how to do it because there's a bunch of letters now and no numbers. Well, I'm here to tell you that there's no need to be freaked out by a bunch of letters, because as long as you know what you're doing and what you're supposed to be doing, it's the exact same rules apply whether there are numbers or whether there are letters there. For example, this says P equals S minus C. Solve for S. So if I circle S, that's what I'm solving for. Okay. Now let me just show you. I'm just going to pretend that P is 10. Okay. And C is, 3. This is an S, not a 5, an S. How would you solve it? Well, if this is the case, you know what to do now. I know that I need to move this negative 3 over. I know that I need to add 3 over to this side. Correct? We know what to do because there are numbers there. Now, let's go back to the original problem. P equals S minus C. And it's the exact same thing. You knew that you needed to add 3 over to this side. It's the same thing, except the 3 is just a C. So I'm going to add C to this side. Same exact step. Okay? So these cancel. Now, since we don't know the values of the variable, okay, we just leave it as it is. It's P plus C. So we just write P plus C equals S. And now it's solved for S, so there is your solution. Okay. Now let's look at number 2. Same thing. Solving for K. If we put values in here for them, you know what to do. If this H were a 10 and equals, and this R were a 5 minus X, we would know that I need to move this over, and so I would subtract the 5 over. Well, the same thing happens. Okay, I know I need to move the R over. It's a positive R, so I can subtract R. The R's are going to cancel. And so since we don't know these values, it just stays as H minus R equals negative K. Now the only difference here is it's not done. This is not solved. This negative sign needs to go. So remember the fact that this is a negative sign, but that there's a 1 actually in front of that K. I put a 1 in front of that K. If you can't see it, there's a 1 there. So in order to get rid of the negative 1 now, since it's negative 1 times K, I need to divide both sides by negative 1. This will cancel. So I have H minus R over negative 1 equals K. Okay. We're going to do a couple more. We'll do 3 and 4 here. So here you have P equals 15 plus 1/2 D. Well, there's a number there, so hopefully we know what we need to do. We're solving for D, so this 15 needs to go. Since it's going to go across the equal sign, it needs to be the opposite, which is minus. Okay, this will cancel. Now, since we don't know what P is, we just have to leave this as P minus 15 equals 1/2 D. Okay. And now we know what to do. We know how to get rid of fractions. We've talked about this. To get rid of a fraction, you multiply by whatever is on the bottom of the fraction. Whatever the denominator is, we multiply. Just remember that when you multiply to get rid of a fraction, you have to multiply everything by that. Okay, do we remember? Let's go back up here to number 6. Here's number 6 here, where we needed to get rid of the 6 in the bottom of the fraction, so we multiplied everything by 6. Same thing applies down here when you're multiplying to get rid of the fraction, you need to multiply everything by that too. Now on the right hand side, this simply just cancels. But on the left hand side, you have to multiply. So 2 times p is 2p. 2 times negative 15 is negative 30. On the right side, equals d. And now it's solved for d. Okay. Last one here, we're going to look at number 4. V equals LWH. What that is just volume equals length times width times height. So we're going to solve for h. Again, bunch of variables here, but let's just make up numbers for them. Let's say that V is, 20. And then LW, I'm going to make LW 10. And then 10H. Well, all of a sudden now, oh, I know what to do. It's 10 times h. I know that I need to divide by 10 and divide by 10. It's the exact same thing. We just put numbers in its place. So when we look at V equals LWH, I'm solving for h here. I can just divide by the LW. Divide by LW. It's the same thing as over here. Now the only difference is here I don't know what V, L, or W is, so it just has to stay V, L over W equals H. Okay. If you have any trouble with that, there is a video that is right after this, right below this, that you can watch. It's from the Khan Academy, and hopefully that helps a little bit. And after that, even after you do all your homework, you can, if you're stuck on your homework and you're stuck on specific problems on your homework, just either watch this video, which you probably, if you're watching this, you already are, and put some question marks on those numbers, and we'll go over them in class. Or just send me a message on Canvas. All right. Hope you had a good weekend, and I'll see you guys on either Monday or Tuesday. This was Cycle 5 on doing literal equations and solving equations with variables on both sides. So, all right. Thank you.